Hey, grade 5, this is Mr. B, and today we're going to be learning about kilometers. So that's our next unit that we're going to be talking about, kilometers. And so this is probably the biggest unit we'll talk about for grade 5. I think in grade 6 you'll probably get into astronomical units and stuff and light years and all that, which will be exciting. But for our purposes this year, we're going to deal with kilometers. So a kilometer, just to start with, is equal, or so we can say 1 kilometer is equal to 1,000 meters. Okay, so, and it's written km, so the full, if we write it out fully, it would be kilometer. And sometimes you might see that I switch this around. It's because the American writing form and the English writing is different. So in America, they write it like this with an ER, and in Britain and Canada and New Zealand and Australia and South Africa, they write it with the RE. So that's just sometimes I get my mind confused, and so that's life. So that's what the short form here is, kilometers. So kilometers are bigger than meters. There's 1,000 meters in a kilometer, and as you can probably guess, there's not very many kilometer sticks. Because this would be pretty massive. So the distance, 1 kilometer is about the distance a person can walk in 15 minutes, right? So 15 minutes, a person can walk 1 kilometer. And if you want to think about this visually in our area, you can think of the distance to the grocery store. So there's I think it's a Foodland. That is, if you were at the school here and you kind of went up and over and then up again and across the lights, there's a set of 4 lights here, and there's a little yard area over here with a whole bunch of stores, a pizza shop, Subway, and a grocery store. And so if you went to this grocery store, or really any of this stuff, it would be about 1 kilometer. So I measured it to here, and it was 950 meters, which is pretty close. So that's about 1 kilometer. Also, if you went to the Ralph Hamlin Park, or the Hamlin Park, there, if you went from our school, and it's basically kind of like down and over, this, with the park over here, is about 850 meters. So a little bit less than a kilometer, but you're kind of getting close. Maybe if you went to the end of the park, it'd be almost a kilometer. So yeah, that kind of gives you a little bit of an idea, and it's about as much as you can walk in 15 minutes. So if it takes 15 minutes to walk 1 kilometer, how long do you think it's going to take to walk 2 kilometers? Well, double the 15, right? So it'd be 15 times 2, which is 30 minutes, right, to walk 2 kilometers. Now, people obviously walk different speeds, but so this is kind of like an average. And for 3 kilometers, right, you're going to be walking, it'll take you 45 minutes. So this is actually something that you could technically use, and we've kind of done this at the beginning of our school year, where we did these patterns. So having this T-chart, you could actually figure out how long it would take you to walk maybe something like 9 kilometers, right? So 9 kilometers, we don't know exactly because we're not just adding 15, but it's a fairly simple thing, right? We would just say, I guess if we wanted to make an equation here, which we're going to get more into equations soon, we'd probably say equals 15x or something, and if the x was the amount of kilometers, you would just say it's 15 times 9, and for our sake we can do this like this, 9 and timesing, and 9 times 5 is 45, so you put the 5 there, the 4 up here, 9 times 1 is 9, plus 4 is going to be 13, and so you'd take about this long together, 135 minutes. And for any of you who know how many minutes are in an hour, you know that it's 60, and so you can get 120 minutes there and take that away and make 2 hours, and then you'd be left over with 15 minutes, right? But that's getting ahead of ourselves. Anyways, you can see that this is kind of a method for figuring out time, right? So if you had to walk 9 kilometers, you could actually figure it out how long it's going to take you approximately, right? Give or take a couple minutes here and there. So we're going to continue now. Oh, it's hard for me to see my little cursor. There we go. So a soccer field. So one soccer field. How do I put a little pin here? Okay, one soccer field is about 100 meters, right? So how many would 2 soccer fields be? So if we had another soccer, I'm not going to draw it. If we had another one right here, a little box here, this would be 200 meters in total, the length from here to here. And now the question is, how many soccer fields could we put in a kilometer? So remember, a kilometer is 1,000 meters equals 1 kilometer. So if we have 100, 200, you could count this out, or you just can kind of guess intuitively. So 100, 200, it would be 300, 400, 500, 600, 700, 800, 900, and then 1,000, and you can count as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you could say that we could put 10 soccer fields into 1 kilometer. So I can give you another little bit of an idea. I think our soccer field at school is a bit smaller than a regular soccer field. But anyways, this kind of gives you an idea of how big a kilometer would be. So just keep going here, marching on. The next thing we're going to look at is converting units. So we have already dealt with millimeters. Oh, that is just a wobbly wobble. Millimeters. We've dealt with centimeters. We've now dealt with meters. And today we're learning kilometers. So this is a bunch of units. And oftentimes we want to be able to change between them. So we remember, if we review, that to go from centimeters to a millimeter, you just times by 10, right? So for every 1 centimeter, you're going to have 10 millimeters, right? And I'm just going to erase this because I don't want to get us confused. But yeah, so 1 centimeter equals 10 millimeters. Now from a meter to a centimeter, we are going to go like so, and it is actually times 100. So there are 100 centimeters in 1 meter, right? So for 1 meter, you get 100 centimeters. Okay, so you're following still? And then now we've learned from a kilometer to a meter, we get times 1,000. Okay, so that is how much. So if you have 1 kilometer, you get 1,000 meters. So these are fairly simple conversions, right? As you see, when we times by 1,000, all we're doing is we're going to add the zeros. Now we can go the other way. If you want to turn millimeters into centimeters, you divide by 10, right? So if you have 10 millimeters and you divide that by 10, you cross out the zeros and you're going to get 1 centimeter, right? So that is kind of how that works, right? So 10 millimeters divided by 10 just for the conversion, and you get 1 centimeter. Okay, perfect. I hope that works out. And then here, the same kind of rule. Instead of timesing by 10, what you're going to do is you're going to divide by 100. So say you had 200 centimeters, and you divide that by 100, you're going to get, basically all we do is you just chop the zeros. So we have the zeros here, we chop them, and we're going to get 2 divided by 1, which is 2 meters, right? Now, so say you had 2,500 centimeters, it would still be divided by 100, and we would chop the zeros out, right? Because they cancel each other out, and you would get 25 meters. Now, I know now I'm continuing too much here, but just for example, if you have 250 centimeters, right? This is probably a better example here. 100 divide, what you're going to get, right? You have only 2 zeros here, and you have 3 zeros here. So you cancel out 2 zeros from each side, right? They cancel each other out. And so you get 250 divided by 1, which is just 250. 50 meters, right? So this is kind of how the conversion works. And just remember, when we're dividing by 100 or 10 or 1,000, we're really just canceling out the zeros, right? And so it's not too difficult once we recognize that rule. Okay, the next one we're going on to is kilometers. And again, it's just a flip, right? So we are dividing by 1,000. So say you had 200 and, well, I'd used that one last time. 370,000, and you divided by 1,000, right? You have 3 zeros this time. You chop the zeros off, and you get your answer of 37 kilometers. Now, just again to beat this one into your heads, if you have an extra 4 zeros, so this is actually 370,000 divided by 1,000 to convert them into, and we should make sure we put meters there, divide by 1,000, and we're going to get cross 1 0 off, 2 0, 3 0, so we're just going to go 1 2 3, and we'll get 370 kilometers. Now, one thing we use kilometers for really is for bigger distances, right? Because each kilometer is a lot bigger than a meter. Obviously, we don't want to be measuring the distance between cities in millimeters, because you're going to get numbers that are just ginormous, and really no one wants to write down or waste time writing down a huge number. So this is why we have bigger units to deal with bigger things. At the same time, you don't want to be measuring a rice grain with kilometers, because one rice grain, right, only makes up like a fraction, a very, very small fraction of a rice grain. It's going to be something like 0.0001 kilometers, and then it's also, right, you're just throwing in all these zeros for no real reason. So we use the right measurement for the right thing, right? Now, just as a note here, there is actually, these are the most commonly used measurements. Almost in everything, these are the ones you'll use. There is other ones. There's you can get into nanometers, and I guess some things on this end, as it gets smaller, there are a lot of, if you're getting into computer engineering and like some science things, yeah, you will get into these smaller units as you look at the microscopic level, right? There's creatures that even using millimeters on them would be kind of counterproductive because they're so small. They're not even a millimeter big, so you can't really talk about them. I guess even if you talk about the coronavirus, right, it would be too small to use millimeters on if you wanted to say what's the diameter of a coronavirus, right? Millimeters is too big, so you'd use different units. But there is some in here. There's the decimeter, and des, if you know in French, right, dix. So you can see the root there, right? So these are all Latin terms, and French is a Latin language, and so you see this kind of root there. This is to go from a meter to a decimeter is actually times 10, right? So there's 10 decimeters in 1 meter, and some meter sticks might have this with a darker line on them every 10 centimeters, or so that could be something. And then to go from a decimeter, it is times 10, right? So this unit is there. So yeah, every 10 centimeters makes 1 decimeter. But in reality, there's very few things you have to measure with decimeters. It would be kind of a sweet spot where decimeters would be useful. Where really you could use just centimeters or meters. Like some things, your foot might be like, yeah, it doesn't really work, right? So you'd have to find something that is like a book or a scarf maybe. But even then, like, it's probably just best to use centimeters because you can get more accurate, and really it's not much of a difference. And that's why these ones are used most often. Okay, stop just blabbing on. We're going to continue here with comparing units of measurement. So say I had 5 kilometers or 3,000 meters. Which one's bigger? Well, if we were just looking at the numbers, we'd definitely say 3,000 is bigger than 5. But we're so smart that we would be like, well, these are meters and these are kilometers. So each kilometer is bigger than a meter. So we can't just compare these like that. What we have to do is convert them. So we have two options. We can either convert the meters into kilometers, which we would divide by 1,000, or we can convert the kilometers into meters, in which case we would multiply by 1,000. Now, my way of thinking is that it's always easier to multiply in my mind, even though this is fairly similar in difficulty. I think multiplication is easier, so I would often choose to multiply and turn the kilometers into meters, but you can do it as you want. So 5 kilometers goes into 5,000 meters, or 3,000 meters becomes 3 kilometers. And once we have 3 kilometers, then it's easy. 3 kilometers is bigger than 5 kilometers? No. 5 kilometers is definitely bigger than 3 kilometers. Same with 5,000 meters or 3,000 meters. So if you had, let's just do another one, 7 kilometers or 13,000 meters. Again, similar thing, right? We just convert. We need to convert. So you say divide by 1,000. And this will be turned into 13, right? 13 kilometers, because you're just canceling out the zeros, right? Chop, 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 and you get this. So 7 kilometers is 13 versus 13 kilometers. 13 kilometers is longer, right? So this is just kind of the conversions that you have to do, and you have to learn how to do them. So really important. Oh, that's not where we want to go. Really important is this sort of thing here. This is quite an important little thing to memorize, basically the conversions. And it's not too hard, right? It's not like if we were teaching you feet and yards where you have 12s and 3 and it gets confusing. Here it's 10, 100, 1,000, right? 10, 100, 1,000. So at least they're all ones and zeros. So we don't get too complicated. Okay, the final thing I want to show you is something that we use this for all the time. Maybe I'll show you the map as well, Google Maps, after this. So if I was traveling from, let's just say, Swift Current, and I wanted to do a round trip all the way around, I wanted to go to Saskatoon, I don't know, pick up a hot dog there, because I have a very nice hot dog place, and I wanted to come around here to Chamberlain to, I don't know, go swimming. I've never been to Saskatchewan, so I'm not sure what you do in Chamberlain or Saskatoon or whatever, but we'll just say maybe this is a nice lake over here, and I wanted to visit here, and so we go to Chamberlain. My, let's say, grand aunt 3 times removed might be there, and I want to visit her. So we go there, and then we come back home, and we wanted to figure out what the distance traveled in a day would be. Maybe we just want to fill up our gas tank enough, make sure that we have enough gas, or just we're just curious, or we're thinking about time, right? How long this is all going to take, because you can only travel so fast, which would take other calculations. But so what we do to figure this out is we normally will break it into sections, right? Today with Google Maps, some of the stuff can be done for you, but yeah, you know, it's still really good to do this in your own brain, right? Everything we do with when we rely on our phones and that sort of stuff, right? What we're doing is we're, instead of using our brain, that's a beautiful brain, we're relying on the phones and the computers, and we're not really allowing our brain to actually grow and get stronger. So it's good to just take a break from using the phone all the time and to get stronger. There was a funny incident where my dad and my uncle were in the park, so in Algonquin Park, which kind of looks like it's a terrible Algonquin Park, but anyways, they were in Algonquin Park along the road that goes through there. It's, I think, Highway 60, and in the park there's no cellular connection, and so my uncle had a map. He was just standing there with a map and figuring out the distances and stuff and which way would be faster. And what happened is, because there was a big traffic jam, right? So that there was a major crash, and so the traffic was lined up, and they were going to be there for maybe 4 hours. And there were other routes. If you went this way, you could maybe come around and back to London, right? So my uncle wanted to come back to London, and this is the fastest way to go here, but there was going to be a 3-hour delay. And so my uncle, he pulled out his map and started figuring this out. He was thinking, and you know what happened was all the people who saw him with a map started coming to see him because no one had a map anymore. Everyone used their phones. But the problem is there's no cellular connection. So if there's no cellular connection, then your phone is useless. So the map became helpful, and so there was a whole crowd of people coming to see him, like, can I look at the map, please? And they were all trying to see what was going on. And so, yeah, right. So we want to be able to use our brains. We don't want to be left empty-handed. And really, this is not the hardest thing, right? So let us take a look here and see this. So if we wanted to figure out the total distance, all we do is just add these together. So we have 269 kilometers here, right? 269 kilometers plus 174 kilometers, and then plus 259 kilometers. Now you could break this up technically into two different, you could add the 269 plus the 259, then add it, but we can just do this all together for our sakes. I'm just going to check that this is actually still on the, okay, it's good. Where am I going? Okay, so 9 plus 4 is going to be 13, plus 9 is going to be 22. So we put a 2 down here. We put our 2 up here. Then we have 6, 7 is 50, or 8 is 8, 2 and 8, 2 and 6 is 8, plus 7 is 15, plus 5 is 20. So we have a 0 here, and we put our, what am I doing? Oh boy, sometimes this marker doesn't work well. And we have 20, so 2 plus 2 is 4, plus 1 is 5, plus 2 is 7. And so we get our 702 kilometers. And so we see that would be the total length of the trip. And what I would know from just seeing this is that my Honda would be able to make the trip. That's a, you can see Mr. B's drawing skills are not fantabulous. But my Honda would be able to make the trip all by itself without having to refuel if the conditions were right and I didn't go speeding or something. Then if I drove properly, we'd probably be able to make it without having to fuel up again, which is going to be quite nice. So yeah, that's good. And yeah, we can look at all sorts of situations like this, right? So this can be very helpful for people to figure out things, right? You want to like plan a trip across the United States or something. You might want to look at a map and be able to measure out, okay, how long is it going to take us to go from this town to that town? And you need to get the distance first, right? And you want to know what it is by segment sometimes, because sometimes you don't just visit one city. Like sometimes when my family was going to Washington, we didn't go directly to Washington. We went first to, I think it was Atlantic City or Ocean City. We went out here, Ocean City. So we first drove out to Ocean City, and then we came back to Washington afterwards. And so we saw the different times. And I guess on another voyage that we did, we went to first from London to Spring Arbor, which is kind of in here somewhere. I don't know, somewhere in here. Spring Arbor, right? We went to Spring Arbor first, and then we went down to that was where Mrs. B was studying. We went down to Cincinnati, and then I think somewhere around here, I just don't remember exactly, is where the big arc is. So that was kind of cool to go and visit. So we were able to check that out. And obviously all these things have importance in different jobs. And if you're in construction and things and you're operating your crews, you might need to know how long they're going to be traveling, how much distance they are. And you might want to optimize your travel of your workers by ensuring that you're not traveling too much or taking bad routes or going along the wrong way. And so these are all good things to know for your future. So I would take time to make sure that you learn how to do these different tasks, and yeah, and they'll be good for you. Anyways, hope that helps. Cheers. Bye.